Right now, Boyajian's star is still flickering, and the astronomers at Yale who have spent years on this have no way to explain it. No model fits, no prediction holds, and what this star is doing in real time could rewrite everything we know about how stars work. But here's what nobody is telling you: the scientists aren't just confused. They're afraid of what the data points to. It sits 1,470 light-years away in the constellation Cygnus. An F-type star slightly larger than our Sun. Nothing about it should have stood out. The kind of star astronomers catalog and forget, but something changed in 2015. Citizen scientists scanning data from NASA's Kepler Space Telescope flagged it, not because it was bright, because it was dying, or at least appearing to. In sudden, irregular, violent drops, it was losing light. 22% of its light gone, then back, then gone again in a completely different pattern. No other star in Kepler's entire catalog did anything like this. Not one. Tabetha Boyajian, the Yale astronomer who led the research, called it the most bizarre star she had ever encountered. She wasn't being dramatic. Here's what makes it strange. Stars dim all the time. Planets cross in front of them. Dust clouds drift through. Binary companions tug at their light. We have a checklist. We run it. We find the answer every single time, until now. The dips Boyajian's star produces are wrong on every level. A planet crossing a star leaves a clean, symmetric shadow. These dips don't. They're jagged, asymmetric, as if whatever is blocking the light has no defined edge and no consistent size. Some dips last hours, some last weeks, and there is no repeating cycle, no orbital period, nothing that maps to any known object in our catalog. In 2017, more than 200 telescopes locked onto this single point in the sky. They watched it dim in real time, across ultraviolet, optical, and infrared wavelengths simultaneously. And what they found made it worse. Different wavelengths dimmed at different rates. That one result alone eliminated almost every conventional explanation in a single observation. So scientists reached for the backup: comets. A massive, disintegrating swarm could scatter dust irregularly, block light unevenly, leave no clean orbital signal. Messy, speculative, but possible. Except the numbers collapse. To block 22% of a star's light, the swarm would have to be enormous, and enormous amounts of evaporating material leave heat. Infrared heat. A signature you cannot hide. They looked. There was nothing. The comet theory died the same week it was published, and then something older surfaced. Scientists went back through photographic plates from observatories dating to the 1890s. What they found stopped the room cold. Over the last century, Boyajian's star has been slowly, quietly, continuously fading. Not flickering, fading. Nearly 20% of its total brightness lost, over 100 years. While no one was watching, now we reach the part they don't say out loud easily. Strip away comets, strip away dust, strip away every natural candidate, and you're left with what researchers have called a hypothesis of last resort. Something constructed. A megastructure around this star, built by a civilization far older than ours, harvesting its energy, blocking its light in patterns that don't repeat cleanly because they were never meant to be predictable from the outside. Most scientists dismiss this fast. Too fast, some argue. But here's the strange part: it shouldn't be possible at all, not the megastructure, the dimming itself. Even stacking every natural explanation available, no combination satisfies all four constraints simultaneously. The asymmetric dips, the wavelength-dependent dimming, the century of gradual fading, and the complete absence of infrared excess. No known physics handles all four at once. Not one model, not anywhere. And then in 2021, a new analysis of archived data found something else. The timing of the star's dips when mapped carefully against each other isn't purely random. It's not a clean signal, but it's not noise either. It lands somewhere in between, something that looks uncomfortably like structure, like a repeating envelope around an irregular core, like a pattern we haven't learned to read yet. But that's not even the part that worries them. If the explanation is natural, if some undiscovered physics is at work, then we have a hole in stellar science so wide that every model of how stars age, dim, and interact with surrounding matter needs to be torn apart and rebuilt. Every assumption baked into the next generation of space telescopes. Every textbook chapter on stellar evolution. Gone. And if it isn't natural, then something has been using this star for over a century. Something 1,470 light-years away is pulling energy from a nuclear furnace larger than Earth's entire orbit while we were cataloging it and moving on. The James Webb Space Telescope has now turned toward Boyajian's star. The data is being processed. The teams are quiet, not the kind of quiet before a press release. The kind of quiet that comes when scientists see something and aren't ready to say what it is yet. So here is the question they have not answered. If it isn't comets, and the infrared data proves it isn't, If it isn't any known stellar phenomenon, then what exactly are we watching? Drop your answer in the comments. Because the explanation they're not saying out loud may be the only one that fits.